All right, open up your book to section 4-6. We are on page 221 in your book. The title of this section is Partial Fractions and Operations with Rational Expressions. The objective is to multiply, divide, add, and subtract rational expressions and resolve proper algebraic fractions into the sum of two or more partial fractions. We'll take care of the idea of partial fractions in the second half of this section. So the first half will deal with the operations with rational expressions. So hopefully this is a review for us. But just to make sure we understand how to work with rational expressions, let's talk about a couple of things. Let's start with the multiplication of fractions. If you have two fractions and you want to multiply them together, then how do we go about multiplying them together? Well, the process here is in order to multiply two fractions together, you just simply multiply the numerators together, and then you multiply the denominators together. Notice that you do not have to find a common denominator to do this. You just multiply the numerators, multiply the denominators. Here's another way of stating this, assuming here, of course, that x is not 0 and y is not 0. If that is the case, then obviously you can't, this doesn't apply here because you'd be dividing by 0. But if x is not 0 and y is not 0, then if you take a divided by x and you multiply it by b divided by y, the result is a times b. Notice those numerators get multiplied together, divided by x times y. Notice that those denominators get multiplied together, and there is our result. Just multiply the numerators, multiply the denominators. So, for example, let's suppose that we want to multiply these two things together here. I've got x over x minus 2, and I want to multiply that by x plus 1 over x plus 3. So again, our technique here is we just multiply the numerators together. In fact, I'm going to just write it in that factored form to start off with, and then we'll go ahead and multiply that out in a second. And then multiply the denominators together. So x minus 2 times x plus 3. And we'll go ahead and multiply these out, FOIL them. So the first, or the numerator turns out to be x squared plus x. The denominator turns out to be x squared. You'll have a plus 3x and then a minus 2x. So that sounds like just a plus x that we simplify to. And then minus 6. There's the product of those two rational expressions. All right. The next thing is the division of fractions. How do we divide two fractions? Well, the technique that we use here, if you want to divide two fractions, then the method that we're going to use is we're going to multiply the fraction in the numerator by the reciprocal of the fraction in the denominator. You've probably said this many times, that dividing by 2, the whole number 2, is the same as multiplying by 1/2. That is the reciprocal of 2, which is 1/2. That's the same property we're talking about right here. You can change division into multiplication as long as you multiply by the reciprocal of the denominator. Or to put it another way, again, assuming that x and y are not 0 here, otherwise we'd be dividing by 0. But if x and y are not 0, then if you have a divided by x divided by b divided by y, so a over x divided by b over y, you could rewrite that using the division sign. I don't like writing it that way myself, but nonetheless, you'll see some problems written this way. If you have a over x divided by b over y, that's the same thing that we see there on the left. You can rewrite that as a product if you reciprocate the denominator. So that's the same as a over x times y over b. And now that you have it written as a product, we just talked about how you multiply fractions. So just multiply the numerators, a times y, and divide that by the product of the denominators, x times b. And there's our result. All right, so let's take a look at an example here. If we have x over x minus 2 and we want to divide that by x plus 1 over x plus 3, or that's another way of saying that we're going to take x over x minus 2 divided by, using the division symbol, x plus 1 over x plus 3. Again, I don't like that second form, but you'll see some problems written that way, so I want to write it that way for you. It turns out that you can rewrite this as a product. So this is equal to the numerator part of this, x over x minus 2 stays the same. And then I have to multiply this by the reciprocal of the denominator. So that's x plus 3 over x plus 1. And let's write it in that form first of all, that factored form. I'm just going to write the product of the numerators, x times x plus 3, and the product of the denominators, x minus 2 times x plus 1. And let's go ahead and expand that, multiply that out, FOIL it, however you want to say that. So in the numerator, you've got x squared plus 3x. In the denominator, we've got x squared. I'll have a plus 1x minus 2x. That's a minus x in the denominator. And then minus 2. There's how we divide fractions. All right, let's take a look at the example in the book there that they give us. Example 1 on page 222. They say to multiply these and simplify, and they gave us quite the rational expressions there to work with. So they gave us x squared plus 5x plus 6 divided by x squared minus x minus 20. And we're multiplying that by x squared plus 3x minus 4, and we're dividing that by x squared plus x minus 2. Now you can go ahead and multiply these trinomials together in the numerator and then multiply the trinomials together in the denominator and be done. I would suggest that you start out by trying to factor this. If you try to factor this and you find some common factors here that you can cancel out, that'll make this a lot easier rather than trying to actually multiply these trinomials together. Okay? We can write what it's equal to and actually write the products here, but I'm going to factor this before I actually try to do anything else. So this would be x squared plus 5x plus 6 times x squared plus 3x minus 4. So that's just the product of the numerators, divided by x squared minus x minus 20 times x squared plus x minus 2 in the denominator. All right, so that's the product of the numerators over the product of the denominators. But rather than trying to multiply that out, let's see if this will simplify here a little bit. Think about the factors of that first quadratic that you have here. X squared plus 5x plus 6. And two numbers whose product is 6 and sum is 5. That sounds like x plus 2 and x plus 3. Now do the same with the second one. So you need two numbers whose product is a negative 4 and sum is a positive 3. So that sounds like you're going to need a positive 4 and a negative 1. So we've got x plus 4 and x minus 1 to make that happen. And now in the denominator, do the same thing. X squared minus x minus 20. Two numbers whose product is a negative 20, but sum is a negative 1. We're going to need a negative 5 and a positive 4, it sounds like. So x plus 4 and x minus 5. And then finally, x squared plus x minus 2. Again, I need a product of negative 2 and a sum of a positive 1. So it's going to be positive 2 and a negative 1, it sounds like. So x plus 2 and then, x plus 2 and then x minus 1. Yeah, and actually there's quite a bit that cancels out here, right? So let's go through and cancel out these common factors here. I've got an x minus 1 that's going to cancel out. I've got an x plus 4 that's going to cancel out. And even an x plus 2 that's going to cancel out. Wow, that gets rid of a lot. So this simplifies really nicely and really easily when we do that versus multiplying those trinomials together. So what do we have here? I have just x plus 3 over x minus 5. But again, I have changed the domain of this original expression now. I need to make sure that I indicate that x cannot be equal to where the denominator was 0, those values that I've canceled out. So x cannot be equal to -4, a -2, and a +1, it looks like, are the three values that I've eliminated when I rewrote it in this form. All right, and then let's talk about how we add and subtract fractions. We're talking about the operations of rational expressions. So how do we add and subtract fractions? Well, to add and subtract fractions, we have to get a common denominator. So to add or subtract two fractions, you have to find a common denominator, and then either add or subtract the numerators. And you divide by the new common denominator. The denominators don't change once you get a common denominator. It's the numerators that you combine. Or to write this another way, again, assuming that x and y are non-zero values, because otherwise we'd be dividing by 0 here. So as long as x and y are not 0, then if you have a over x plus b over y, then you want to get a common denominator, and the easiest way to do that is to multiply by a clever form of 1, where that clever form of 1 that you're multiplying by comes from the other fraction. So the fact that this has a y in the denominator is the reason why I'm multiplying by y over y here. And the fact that this first fraction has an x in the denominator is the reason why I'm multiplying by this x over x that shows up right here. Okay? Multiply by a clever form of 1 to make that happen. And then once you have a common denominator of x times y, you can now add these two fractions together. Just add the numerators, ay plus bx. And that's all over x times y. All right, so let's try an example of this. Example number 2 there on page 223. They say to add by first finding a common denominator. Well, that was nice of them to give us a little hint here to remind us how we add fractions, but I would expect that you remember how to do that, of course. So we have 3 over x plus 4, and we're adding that to 5 over x minus 7. All right, so again, we got to multiply by a clever form of 1. So I'm going to look at this denominator over here, and that's going to help me figure out what to multiply this first fraction by. I'm going to multiply by x minus 7 over x minus 7. And then I'm going to look at the other denominator here, x plus 4, and that's going to tell me to multiply this fraction by x plus 4 over x plus 4. That's how we pick the right denominator in order to get or the clever form of 1 in order to get a common denominator. All right, so what do we end up with when we multiply this out here on the left? I'm going to write it in factored form first, and then we'll evaluate this. But 3 times x minus 7 over x minus 7 times x plus 4. That's the first fraction. And then in the second fraction, we'll have 5 times x plus 4. Again, we're multiplying fractions here. So you just multiply the numerators and then multiply the denominators. And then x minus 7 times x plus 4 is the denominator. And now you can see that the numerators, that the denominators are the same. So as long as the denominators are the same, we can add these two together. So we've got 3 times x minus 7 plus 5 times x plus 4. This is all over our new denominator of x minus 7 times x plus 4. All right, now let's simplify this. Again, you could be simplifying as you go through this, but I'm going to simplify at this point here. In the numerator, I've got 3x minus 21 in that first product. And in the second part, I've got 5x plus 20. In fact, I think I'm going to go ahead and multiply the denominators together here, the two factors that I've got there. So that's x squared. You'll have a plus 4x and then a minus 7x, so that's a minus 3x, and then a minus 28. And then finally, the numerator is really just linear, so let's simplify that. So what do we end up with? 3x and 5x is 8x. You got 20 and a negative 21, so that's a minus 1, it looks like. And that's all over x squared minus 3x minus 28. There we go. That's how we add or subtract fractions. All right, that's the first half of section 4-6.